A significant problem in systems of all kinds, but especially safety-critical embedded systems, are counterfeit components. How do you know that components are legitimate? In some types of applications, the market is awash with fake, illegitimate components. These components might fail to meet some specifications, but superficially have the same function. So that looks like they work, but maybe they don't have as good a temperature rating, or maybe they don't have the same wear-out functions. So when they're sold, nobody can tell anything's wrong. So they'll fail in service, potentially causing a loss event that should not have happened. Some counterfeits are wholly fake, but some of them are more subtle. Some of them are rejects that failed some sort of testing. For example, a system will fail a speed test or fail a temperature test and be thrown away, but someone will dumpster dive the discards and sell it as a legitimate component. And for all purposes, it is a legitimate component. It was made by the manufacturer, but it failed some test, and whoever buys it won't know that until the system encounters that extreme condition, perhaps years later. Sometimes there's salvaged used components that a system is retired or a board fails and is tossed away, and someone repairs the board, but maybe they don't use the same quality repair components, or maybe the board is near end of life, so it wears out quicker than expected, causing a problem. Sometimes there's clone hardware that has a reduced parts count to save cost. So for example, there might be a power supply that regulates power just fine until a component fails, but there's no safety mechanisms. So when it fails, it catches fire instead of doing a safe shutdown. Ask yourself, what if a fake like this shows up in a critical application? This is a big concern in aviation, but as cars become more safety critical, for example, fake counterfeit components inside self-driving cars are going to be an issue that has to be dealt with. The size of this problem is that U.S. Customs seizes 1 or 2 million fake integrated circuits per year, and that's just the ones they catch. So this is a significant issue that you will need to deal with if you're building a critical system with a long supply chain. Beyond counterfeit components, what if someone wants to clone your entire product? They may take products that failed acceptance tests, or they may take products that have been retired or disposed of because they're broken. They may fix them up, but not to the same high standards as a factory refurbished component, and they may sell them at a discount or deploy them. Tamper-proofing might help, but if the attack is worth a lot of money, somebody will figure out a way to reverse engineer your tamper-proof system and start making clones. There are cases in which the clones are built by scavenging authentic components. For example, they may find a source of replacement cases, and then you manufacture an internal circuit board that's counterfeit and not up to spec, but the external case is the same, the nameplate is the same. How's a customer supposed to know whether or not the entire thing is authentic? Generally, if you need to combat clones of your whole product, you need some sort of way to authenticate and track serial numbers of your product. And you probably need a secure serial number so that an attacker can't guess a valid serial number, but at best can reverse engineer one component and issue a whole bunch of components all with that same serial number. While ultimately you cannot stop them from doing that on a technical basis, you can at least say, here's a serial number that is known for counterfeit. Anything with that serial number we're going to assume is a counterfeit, and we're not going to provide support. We're not going to provide warranty. And if we get sued because it failed, we're going to say, no, that wasn't ours because that's a known counterfeit serial number.